one of my preferred materials are carbon nanotubes. If I want to describe them, we can start to look at the pencil. So the black part of the pencil is a graphite, and everybody nowadays know that is a layered structure. The layer is called graphene. But if you take this graphene layer, you started to roll it, actually you make a new object that exists in reality. This is a carbon nanotube. If I roll it in this way, this material will act as one of the best semiconductor we know, so much better than the silicon we use to make transistors for our smartphones or TV and so on. But if I roll it in the other way, in this way, we get the nanotubes that act as very good conductors. So they're like metals, like copper, like gold, and so on. So not only the size determines the properties, but also the rolling direction. And this is peculiar of carbon nanotubes. The problem is how I can select a nano object from a bunch of objects that look more or less similar. And what we found together with other researchers, that there are some polymers, some macromolecules, that have a strange affinity, and they like to roll around the walls of the carbon nanotubes. But they don't like to roll around all of them. They like only some of them. And in particular, they like only the one that are made like that. And there are the good ones to make electronic devices. So we have a kind of ink where there are the carbon nanotubes. And once we have them in an ink, what we can do, we can just put them in a substrate and make a transistor with them. And this is a little bit what we are doing. This was nice to see. So these are our nanotubes with the molecule around, and then we put them in, this is our transistor structure. So we have some oxide layer, we have gold electrodes, and we put the carbon nanotube, just a drop of liquid on the substrate. And you see here, these are all our nanotubes just lying on the substrate. And when you apply a bias, you see here, they behave like a very good transistor.